So today in this video we are going to discuss why 0 factorial equals to 1. So in this video we are going to discuss 4 different types of proof for 0 factorial equals to 1. So first we'll see the proof of the type combinatorial proof. We say combinatorial proof, and secondly we'll see proof using factorial formula, and third one we'll see formula using binomial coefficient, binomial coefficient, and at the end we'll prove by my favorite method. Yeah, so let's discuss one by one. So first one is combinatorial proof. So in this proof we'll see how the combinations work or arrangement works. So first let's see what is mean by arrangement of object. So suppose I have a letter A. For letter A, we can arrange this letter A into one way only, that is A. Yeah, so if I take letters for letters A and B, so if I want to arrange these letters A and B simultaneously, so means if I want to arrange these letters in a group, so we can arrange it as AB and BA. Similarly, if I take three letters for letters A, B and C. So let's see in how many ways we can arrange these three letters in a group. So we can arrange it as simply A, B, C, or A, C, B, or B, A, C, or B, C, A, or C, A, B, or C, B, A. So when you observe here, when I am arranging only one letter, so there is number of we get number of combinations only one, and for arranging two letters the number of combinations or arrangement is 2, and for arrangement of three letters we have 6 arrangements. So in similar way, if I say if I have number of letters 0, so for number of letters 0, how many ways in how many ways we can arrange this? So we can arrange it in only one way. Yeah, so we can arrange 0 letters in one way. So here the number of arrangement, so here the formula, what formula is, so formula is we can arrange n objects or letters. So let's try to make the formula or observation. So for 1 we have 1, for 2 we have 2, for 3 we have 6 arrangements. So for 1 we had one arrangement, for 2 we have 2 arrangements, for 3 we had 6 arrangements. So when you observe the same pattern you will get For 4 you will get 24 arrangements. And here is a pattern. So what is the pattern? Pattern is that the for suppose I know the arrangement for first object. So to get arrangement for second object, what we do? We do multiply by 2. Yeah. And similarly for arrangement of three objects, we multiply by 3 in number of arrangements of two objects. Yeah. And for 4, we can find the total of arrangement by multiplying 4 in number of arrangement of three objects. So, and we denote it by as, we'll say later on, we can denote it by means this one is can be written as like it 1 factorial, 2 is 2 factorial, 3 is 6 is 3 factorial, and 24 is 4 factorial. So the factorial is defined as means we define the factorial as, suppose I have n factorial. So what I do, I will multiply all the natural numbers less than or equals to n. So that is n into n minus 1 into n minus 2 up to 3 into 2 into 1. Clear? So when you see the number of arrangement and the formula thing, so we can arrange n objects or n letters in n factorial ways. So moreover, we can arrange 0 object in 0 factorial ways, that is 1 ways. As we had already discussed, we can arrange 0 elements in one way. So now let's move to the second method of proof, that is using factorial formula. So we had a formula n factorial equals to n into n minus 1 into n minus 2 into up to 3 into 2 into 1. So when you observe here, these n minus 1, n minus 2 into up to 3 to 1, product of these numbers, so we can see it as n minus 1 factorial. So now we have n factorial equals to n into n minus 1 factorial. And since this formula hold for all the natural numbers, so we can put n equals to 0, 2. So when we put when n equals to 1, we get 1 factorial equals to 1 into 1 minus 1 factorial. So 1 factorial is 1, 1 into and 0 factorial. So any factorial into 1 is 1. So that quantity. So 1 equals to 0 factorial. So this is the second part of our proof. Yeah. And third one is the binomial coefficient reason. Third one is binomial coefficient reason. So what is binomial coefficient reason? So this is a formula which says we can arrange or we can choose. Basically, we can choose n r objects from n objects in. We can choose with this binomial coefficient is a basically it is a formula which says nc0 or NCR equals to n factorial by r factorial into n minus r factorial. So this formula, we can use this formula to find the what? To find the number of selections, to find the number of ways to select r objects from n objects. Yes. So if I want to choose zero object from n objects, so now we want to choose zero object from n objects, and clearly this can be done in only one ways. Clearly this can be done in one way, and that way is we are not going to select anything. That's even that is a method, that is a possibility of choosing. I'm not choosing anything, I'm not selecting anything. Yes. So that is what we get nc0 equals to 1, but by formula we get nc0 as n factorial by n minus r factorial, that is 0 factorial, and then again n factorial, no, r factorial already, but n minus r. So n minus 0 factorial, it is n factorial by 0 factorial into n factorial. So when we divide n factorial by n factorial, we get 1. So equal to 1 by 0 factorial. On solving, we get again 0 factorial equal to 1. Yeah. Now we'll see our last one, that is my favorite. My favorite. Fourth method. My favorite. Method. So why it is my favorite? Because it's based on true observations from different formulas. So let's see. We know 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. But what about 0 factorial? I don't know what is 0 factorial. So we'll see it in some different pattern, some form of patterns. So let me recall some basic formula. So suppose, what is 2 raised to 1? It is 2. What is 2 raised to 2? It is 4. What is 2 cube? 8. 2 to the power 4, 16. Yeah. So let's see while reversing. So when I go 2 raised to 4 to 2 raised to 3, what I am doing? I am dividing by 2. While going 2 cube to 2 square, again I am dividing by 2. Again you can see I am dividing by 2. So while going from 2 raised to 1 to 2 raised to 0, again what I do? I will divide by 2. So after dividing by 2, I will get 1. Then again, after dividing by 2, that is to get 2 raised to minus 1, what I get? I will get half after dividing by 2. So in similar fashion, I can get values of 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4. Yeah, you can calculate it. So now similar thing when you observe here, what I am doing, from 4 factorial to 3 factorial, I am dividing by 4. From 3 factorial to 2 factorial, I am dividing by 3. From 2 factorial to 1 factorial, I am dividing by 2. And then again from 1 factorial to 0 factorial, what I do? I will divide by 1. And then what I get? I will get 1. You got it? Yes. That's it. So now the question is, what is minus 1 factorial? Can you find? If you have any answer, please share with me. Yeah. So that's it in this video.